This is example 5. We are again given a h of z that looks like this, and we are asked to find h of n. So this is the typical problem. The first thing you will notice is that this is a improper rational function. One way we can solve the problem easily is to express this as 1 over 1 minus 2z, and then the other one is plus 5z minus 1. So we very easily can express it in this way, and therefore they become a proper rational function, and then we can use the lookup table. Now in this example, he told us that we are interested in causal sequence, therefore the answer should be all causal. So look at this, answer is all causal. Now when we have this expression, it's easy. The immediate answer is the lookup table of inverse Z transform of this expression is nothing but 2 to the power of n u n. What about this guy? 5z minus 1, this guy. So the trick is just do this first. So we have plus 5 here first, z minus 1 here. Now we do the inverse Z transform here. This is nothing but 2 to the power of n u n. Now what's this z minus 1 here? What you realize is that this z minus 1, we can use a property that when z minus 1 of an expression is nothing but 5 to n minus 1 u n minus 1. So z minus 1 is a delayed version. Z minus 1 is a delayed version of the original sequence. So where did we get this? So I'll work it out here. If we have hn, the Z transform hn is hz. What about h of n minus 1? The Z transform of hn minus 1 is z minus 1 hz. So you realize that once you have figured out h of z in h of n, then all we need to do is to substitute all n to be n minus 1. So that's what we did in the top. Now, this question has another part, is that actually there are a few ways you could have solved the problem. You could have taken this and performed long division, and you could have gotten this. So these two expressions are identical. This is an improper rational function, this is a proper way. So it is some constant plus 7 over 2, 1 plus 2z minus 1. Now, if you have done it this way, then of course you can then perform Z transform for each of these expressions. So minus 5 over 2 is minus 5 over 2 delta n. And this guy is plus 7 over 2, 2 to the power n u n. Now, then you say, how come I have two different answers for the same guy? Because this guy and this guy sure looks different. Actually, if you plot them out, they are the same. It's just two different ways for closed form solution for the same thing. So don't become confused. And we actually prefer the second way because it has one less pole to deal with. This is only 2 to the power n one time. This has 2 to the power n here. This is 2 to the power n minus 1. So computationally, of course, this is more expensive to implement than this guy. Okay, so that's it. So the take-home message is there are multiple ways to perform the inverse Z transform, and each of these ways will give you the answer in different expression, but they are the same answer. Okay, thank you.